Madam, is it visible?
Yes.
Yes, sir, visible, sir.
Okay. So first of all, thank you, the organizers, for inviting me to this AICT training and learning, means ATAL FDP on energy sustainability and climate change. And my voice is sufficiently audible to everyone?
Yes.
Yes, sir.
Okay. So today, my topic of presentation would be floating solar PV. One of the interesting topic in my research area. Recently, I have started working on this particular topic. So some updates. Presently, I'm working in IIT Mizoram as Dean Academics. Previous year, I was the Associate Dean Student Welfare. So, and some of the important items that has not been in many people may not be knowing is that this particular program is organized by the Institute of Technology, and I am one of the alumni of this institute. Means to say that I have completed my diploma in mechanical engineering from this particular institute in 2004. And after that, many things, many colleges, many places I visited, but that is the foundation that in my life in mechanical engineering from this particular institute. So let's start the presentation. So first of all, we are talking about this particular FDP, it is energy sustainability and climate change. So my first one, I think 2-3 slides are around that. So when we talk about the energy sources, we are talking basically about altogether different sources of energy. It may be non-renewable energy, it may be renewable sources. So why we are discussing those? Because one of the important topic nowadays, the energy. There are certain reasons, and this reason is not new. It is more than 50 years already, that global issues on depletion of fossil fuels, means coal, gas, or oil. Now, thing is that still we are much more dependent on the non-renewable sources, we can say, coal, gas, and oil mostly. Because although we are saying that the reserve for the non-renewable sources are depleting, but at the same time, our majority of the production actually coming from those non-renewable sources. And there are means thousands or lakhs of scientists are working on how to reduce the emissions from those non-renewable sources, because the research or progress on the renewable energy sector is there, but still not on the speed that is how the demand is growing. So yes, fossil fuel reserves are depleting slow day by day. At the same time, the price of the electricity also increasing. There are certain incidents happened because of this fossil fuels, for example, nuclear disaster that we have seen in Japan. Then obviously global emissions, they are there from this coal, gas, and oil burning. On the other side, when we talk about the renewable energy sources, the different sources are hydro energy, wind energy, solar, tidal energy, geothermal, biomass, etc. Now, those energies are very much dependent on the location, or very much very much dependent on the availability itself. For example, wind energy may not be suitable in all the locations. The place, although I have yes, I can say I have some fundamental background on the wind energy. I worked in the field for 13-14 years. So, but when I come to Mizoram, I check the wind speed. It is more or less between average wind speed is 1.5 to 2 meter per second, which is not really sufficient to generate any electricity from the wind turbines. When you talk about the hydro energy, again, it depends on the reserve that we have on that particular location, whether sufficient hydro current is there or not, whether sufficient resources are there or not. Biomass energy may not be suitable for any urban states. but it is suitable, particularly in any stage, definitely it is suitable. Geothermal energy, again, dependent on the particular location. And then tidal energy, whether the sufficient tides are there or not. And solar energy intensity also depends, although it's more or less everywhere available, but intensity varies from location to location. So all the energies, renewable energy sources, depends on the location, and the selection of the particular renewable energy also uh, depend on the what is available on that particular site, as well as what kind of at what scale we are going to propose that particular renewable energy. Another theme of this particular FDP is sustainability. So when we combine the sustainability factor with the energy, the term comes sustainable energy. So sustainable energy, when we talk about, so what is the sustainability term? The sustainability basically defines as meeting the present need or present demand without compromising the ability to for the future generations to meet the future demands. And it has three pillars: social pillar, whether in the long run it will be acceptable by the society or not; economic pillar, that is whether in the long run it is economically viable, or at the present time also whether it's economically viable; and environmental case also. Environmental sustainability, we have to look whether environmentally it will be supported, or we can, in another word, we can say that it will not create the causes for the global emission or environmental pollutions. So if any particular energy is satisfying the three pillars, we can say that this is a sustainable energy. So if any particular energy is available, that does not mean that it is a sustainable energy. So we call it sustainable energy only it meets the three pillars. Okay, now renewable energy supply, we can see here for the different areas. So we distributing here the major energy eating sources that heat, fuel, and electricity. So those are the major eating sources. So in that we can see that heat is around 48.7%, where in that 48.7%, 9.9% is coming from the renewable heat. Then on the fuel sector, it is 3 out of 28.6%, 3.7% is biofuel. On the electricity, out of this 22.7%, 30% is coming from the renewable electricity. More or less 30%, it is 29.9%. As per the Renewables 2023 Global Status Report, it is not my data. Definitely, I have taken data from somewhere. Now, if we go a little bit inside of this renewable electricity generation, we'll see that in last one decade, from here the data is taken from 2012 to 2022. We can see that here the renewable electricity is 21.3%, and out of that 16.4% was hydropower, 2.8% was solar and wind power, 2% is bioenergy and geothermal power. So mostly these are the dominating contributors to that renewable electricity of 21.3%. After 10 years, when I come here, then we can see that hydropower is 15.1%, solar and wind power is 12.1%, and 2.7% is bioenergy or geothermal. Please do not confuse between this particular, because it's in percentage form, so it is not really indicating the installed capacity. So we can see here 16.4 to 15.1%. That does not mean that hydropower contribution has been reduced. It is percentage-wise reduced when you have solar and wind contribution is significantly increased. So in the renewable energy, you could say divisions, we can see that the solar and wind power contribution has been significantly improved thanks to our government policies and push towards the renewable energy sector. And at the same time, fossil fuel contribution as a percentage was, it has been reduced. So overall installed capacity, if we look into that, then we can see that the more installations are done in this particular sectors comparatively to these two sectors. So that's why the percentage wise it is being changed. Now, so this particular table is taken from the India Energy Outlook 2021, and it indicates that by 2040 there will be significant contribution which is expected from the solar PV and wind. When we get to see the total capacity is if capacity is 1552 gigawatt, then we can see the renewable energy contribution has been significantly improving. So that also indicates that how the policies and government is targeting towards more towards the renewable energy sectors. So we are highlighting these particular sectors here. Now, when our next slide will be something related to energy statistics and the market. So before that, this slide is intentionally here. It is LCOE, it's a levelized cost of electricity. Now, levelized cost of electricity means sum of cost over lifetime by sum of electrical energy produced over lifetime. Now, if we look into the different energy sources, here it is a utility scale solar, utility scale wind, and gas. So we can see that the solar pricing has been reduced significantly over the time. Here 2009 2018 we have seen, so 7 cents per kilowatt hour to 2 cents per kilowatt hour. So a significant drop in the pricing of the electricity production, we can see. And this research has been done by Berkeley Lab, University of California. So although the research, the amount, the percentage reduction may not be exactly same for our context, but it shows the indication that how significantly the prices has been reduced from in last 10-15 years. Now, as per the ARENA report 2023, we can see here this LCOE, this levelized cost of electricity production, how it is predicted for next 30 years. So we can see here nuclear, it is not significantly reduced, coal not significantly reduced. We can zoom it also. So it is not so significantly reduced. However, when we go to this solar PV, you can see here the LCOE is significantly reduced, wind also slightly reduced here. And if it is offshore wind, the pricing will be significantly reduced thanks to the advancement of the technologies to improve the efficiencies of different energy devices. At the same time, thanks to our materials researcher or different technological developers, who are actually giving us low cost materials with better characteristics. Now, if we see the breakdown, madam, slides are moving. Anybody can confirm?
Yes, yes.
Okay.
Slides are moving.
Okay, thank you. So it is a solar installation capacity in top 10 Indian states. We can see Rajasthan is leading with the 18.07 gigawatt. So they have plenty of solar installations in that particular state. Then we can see here Gujarat, 10.13 gigawatt. Then Karnataka, Tamil Nadu, Maharashtra, Andhra Pradesh, Madhya Pradesh, Telangana, Uttar Pradesh, and Haryana. So we can see here how the solar energy installation capacity has been distributed among these top 10 solar contributors. However, we have not included the other states, but definitely there are many contributions from other states as well. Now we go inside the floating solar PV systems. So floating solar PV systems, when we talk about that particular energy systems, for some of the aspects of the solar floating devices. So one is solar modules. So solar modules will be same as our ground mounted or rooftop systems that we see normally. These are having similar type, having efficiency around 20%, means it depends on the solar PV systems as well. So panels also. So it is roughly between 15 to 25, we can say, in that particular region. Then since the solar panels are almost same, the cost for the solar panels will be also in the same. But when we talk about the tracking mechanisms or other control mechanisms for the solar PV system, there are sufficient potential for research progress for the floating systems. Then sites normally, so when the floating solar PV or FSPV systems are being introduced, those are being introduced for the artificial water bodies or reservoirs, ponds, those, and slowly it has been transferred to the river systems, to the different hydrodrums, and then now offshore locations for the large scale floating solar PV systems. For structure wise, there are many materials are being tested to develop the lighter and more stronger structures. So as a mechanical engineers or those who are working in the material science, definitely there are a lot of potentials on the to work on the floating structures and for the floats, and also working on the structures that support the solar PV panels. Another aspects for this floating solar systems are the anchors and mooring lines. Those are being used particularly for the offshore locations. So when we talk about the large scale floating solar PV systems, anchors and mooring lines are very, very important. So a number of research are ongoing on that particular sector. Then electrical components. For the electrical components, land-based photovoltaic system installation, how we see it is little bit different to that, because for the electrical components, we have to see at what scale we are proposing the floating solar PV systems, whether this is close to the land area. If yes, then whether it is possible to have all the electric components, for example, inverters. I'm not an electrical person, but as a so overall idea, what I can understand is the inverter, transformer, transmission lines, those will be installed in the nearby land. Whereas if it is in a large scale installation and you are installing on the somewhere a little bit far from the land area, then the inverters, transformers, those examples are also there. Those are in a floating platform. In either cases, we have to take care for the electric cables, so that there is no issue of there is a short circuit or any damages because of the electric cables or any accident happen. So those are the different areas that for floating solar PV systems need to be explored further. Some comparison on the floating solar PV system, some relative advantages, disadvantages when we talk about the ground mounted PV. Ground mounted PV is the low cost PV system comparative to floating PV systems because of the initial low installation cost for the ground mounted PV. And then normally horizontal even seasonal tracking is possible because we have the flexibility to implement different kinds of tracking devices for the ground mounted PV. However, we have certain limitation on the floating PV conditions. However, research is ongoing and people are trying to develop different systems. Then PV modules are easier to clean and maintain. It is obvious if it is a ground mounted PV. Although it is obvious, but at the same time, when I look into some of the areas in Mizoram, even when we visit, particularly in the rural villages, we see that although the government is taking initiative to promote the solar PV, but after installation, after 1 or 2 years, because of the low maintenance or less cleaning, you can see that PV system efficiency has been reduced significantly. So some of our students are also working to develop some cleaning mechanisms so that the villagers need not to go and see again. Particularly those are being used for the agricultural purposes. Then some of the disadvantages for the ground mounted PVs are the limited land availability, particularly in the urban locations. So floating solar PV, if nearby water bodies are there, then it will be much more useful. On the other hand, when you talk about the floating photovoltaic systems, then one of the important aspect is we are not going to install it on the land, so we are installing in the water surface. So there is no question on the availability of the land. Then from the mechanical engineering point of view, we see that a decrease of temperature related losses will be significantly lower if we can have a floating solar PV systems. The reason being that every solar PV system is designed for certain temperatures where they have the maximum conversion efficiency. And normally it is between, I think, 25, 26, 27, around that value, 26 degrees centigrade. However, with the global warming, you can say that nowadays the temperature, even in the winter locations, even in the summertime, we can see the temperature has been significantly increased. And if we talk about the seaside areas, the temperature is normally 40 degree, 35 degree, 45 degree. So solar PV efficiencies, conversion efficiency normally is reduced by a significant amount. So if we can use the floating solar PV, there is a decrease of heat temperature related losses. Then another important factor is reduction of water evaporation. Now, although we can see that India is blessed with sufficient water, but at the same time, how much water is actually drinkable or sweet water? So again, there is a question mark on the water availability. So if we can use the floating solar PV, the reduction of water evaporation is there. So we'll see also some of the examples of the later on the floating solar PV systems. There some mentioning was there, how much percentage of water being saved if floating PV systems are being installed. Then some of the improved water quality and algae growth. So those things are also there as an advantage. Whereas in the disadvantage sector, we can see that potential corrosion of PV components is obvious because we are installing our device on the floating structure. So there are sufficient chances are there to have corrosion on the different components. Then if there is water related events, particularly those which are located in the offshore locations, in the seaside areas, those are tides, storms, cyclones, those also need to be accounted for different to say restrictions to some of the damages. Then if we install a large scale floating solar PV, definitely there is an obstruction to fishing, transportation, or means water transportation of recreation activities. Then access for cleaning and maintenance of the PV modules is not easy as it is for ground mounted PVs. Then cleaning of bars dropping, but that means the solid accumulation on the solar PV panels. The chances are there if we are not doing proper cleaning and maintenance of the PV modules. So hence the efficiency for the conversion of the solar energy will also be reduced. Then the movement of floating platform and consequent mechanical stresses also need to be accounted. So those are also we need to work, particularly those who are working on the floater design. Now, if we see percentage-wise breakdown of a solar PV system, we can see that normally the balance of systems accounts for 4%. Balance of system means these all components of a photovoltaic system other than the photovoltaic panels. So it including wiring, switches, mounting systems, inverters, battery bank, battery chargers, those items. Then cabling is around 10 to 12%. Inverter is around 8 to 12%. Floating platform, which is a significant cost in the floating solar PV, it is around 30%, so 35%. Then anchoring and mooring 2%, installation 2%. Then solar PV modules is 35 to 40%. So if we compare with the ground mounted solar PVs, so definitely we can see that around 35 to 40% increase is there, because floating platform we have to consider, anchoring and mooring we have to consider, then the cabling charges will be increased. Possibly some installation charges will also be increased. So there are around 35 to 40% overall expenditure will be increased, particularly for the initial cost. So that is also one of the factors that we have to see. But in the long run, when you have a comparably higher efficiency, then it may be mitigated over the lifespan. Now, this slide, this particular image I like very much, because this particular image covers almost all the aspects of floating solar PV. So it says some advantages, some drawbacks all together. So we can see here some of the advantages are reduction in evaporation losses, then easy deployment. If you have a floating structure, then no land requirement. Then we can see synergy with the electric infrastructure. If we are combining with any hydropower plants, then already the different electric components will be there. So there can be a synergy. Then we can have here increased energy yield from cooling effect of water. That means the solar conversion efficiency will not be reduced. So in that sector also, we can have an advantage. Then possible reduction in LV growth and water available for cleaning. So for cleaning of different solar PVs, we can have the water on spot. So there are some advantages. On the other hand, some disadvantages we can see here. The electrical safety and longevity of the electric equipments. So that is one of the disadvantages in the long run. Then maintenance will be a little bit comparatively costly as compared to your ground-mounted PVs. Then possible environmental impact from light reduction, that means the life in the sea. Then mooring and anchoring, it is a comparatively complex systems, particularly when we are discussing about the large-scale implementation in the seaside. It may not be that much complex for small-scale installations in the ponds or in a particular area. But when you talk about where you have to face the tides and waves, then the mooring and anchoring is a complex mechanism, complex items in that particular floating solar PV installations. Then possible swelling by birds, that is also one of the reasons. Okay. Now, if we look into the global installed capacity for floating solar PV, so this data is for S&P Global. I think S&P Global report 2023. From that report is this particular data has been taken. So it shows that 4.3 gigawatt by the end of 2022, where Asia Pacific region accounts for 87% of the total installed capacity. Now we can also see some of the important aspects here. See how fast it is growing. So the birds, if we see in last 5-6 years, it has grown significantly. So floating solar PV is not something very old concept. It is comparatively new, and many projects are ongoing in India. Also, we'll discuss on that later on. So we can see here this particular pink bar is representing the Asia Pacific region and how majority of the contribution in the floating solar PV systems are coming from the Asia Pacific. On the other end, now slowly the Europe is also growing, followed by Middle East and Africa, and then American countries. Now, in 2024, as per the report, the floating solar PV installation capacity has been increased to 6.7 gigawatt and a projection of 30 gigawatt by 2030. So there will be significant amount of research, or you can say followed by research, the installation of solar PV projects in different areas in globally. Now, some of the floating solar PV systems across globe. So we can see the Walden, Colorado, USA, 75 kilowatt is comparatively a smaller installation. We can see here Ramagundam, Telangana, one of the largest solar parks in Telangana for India. Then Kyoto City, Japan, 2.8 megawatt. It is comparatively smaller. Singapore, we can see here 60 megawatt. Then China, 150 megawatt. I think China having another floating solar installation, which is accounts for 320, and they have some works ongoing for around 500 megawatt capacity also. South Korea is 40 megawatt capacity. We can see Hapcheon, some installation of solar PV. Now, we'll see now some of the important solar PV projects that are undergoing or already commissioned in India. So one of the project is Omkareshwar Floating Solar Power Project, Madhya Pradesh. It is going to be the largest floating solar power project of capacity of 600 megawatt. So it is a very large scale. So we can say it's the largest solar project still now not commissioned, but it is undergoing. So we can say that this project will bring, see here, will bring into account that a carbon dioxide reduction in the emission by 1.2 million metric tons each year, which is comparable to the environmental benefit of planting 15.2 million trees, means around 1.5 crores trees. And as per the claim that the evaporation of the water will be reduced by 60 to 70% if we have this particular floating solar PV installation. So according to report, this amount of corresponds to drinking water supply for the residents of Bhopal for a duration of 124 days. So we can see how is the effect of floating solar PV projects. So almost 60 to 70% of evaporative water will be not evaporated, and that will be sufficient for 124 days for supplying of drinking water. Then another project that is just now we have seen, it is Kayamkulan floating solar projects, is Kerala. In Kerala, it is 101.6 megawatt. I think this is the largest commissioned floating solar power plant. There is another one, I think around 100 megawatt. So Tata, that is developed by Tata, and it is with the 350 acre water body, about the 350 acre water body. And this particular floating solar power plant contributes to a reduction in carbon emission by 1.42 lakh tons per year. And this particular floating solar power plant, it is to generate an estimated of 167 gigawatt hour of energy annually. So it comprises of more than 2 lakh solar modules, and it has the capacity to provide electricity to 26,000 households each day. So it is a significant project by the government of India that has been commissioned in 2022 in Kerala. Then another project was there in Telangana, that is we initially discussed. So that is commissioned in 2022. That particular projects, so we have 40 blocks and each of 2.5 megawatt capacity. And there are 11,200 solar modules per block. Please do not confuse between solar modules, because solar modules, one particular panel may have one or more solar modules, and one modules normally having 60 to 72 solar cells. And this particular project is developed by NTPC through VEL, Power Heavy Electrics Limited. And we can see here some of the items. So this facility is expected to significantly reduce water evaporation by 3.25 million cubic meters each year. So, and also it is helping in the reduction of carbon emission by more than 2 lakh tons of CO2 emission. So these particular projects also, we can see that how large scale floating solar projects are being installed in India in different states. Then another project that is undergoing and yet to be commissioned is Rian Dam floating solar power plant in Uttar Pradesh. So that particular project is actually with the two companies, Renew Solar Power Private Limited, who is having a power capacity of 100 megawatt, and Sapoji Paloni Infrastructure Private Limited, that is 50 megawatt. So the two companies are together developing this Rian Dam floating solar power plant. And as per the contract with the Uttar Pradesh Power Corporation Limited, for a duration of 25 years, after the commissioning, they will be supplying to the government, means UPPCL, at the rate of rupees 3.36 per unit. Then some more projects are going on in Andhra Pradesh, Simadri floating solar power projects by NTPC, which can supply the power of 25 megawatt. And we can see here it saves the water evaporation of 1,364 million liters of water annually. And this is substantial. This substantial water consumption can meet the annual water requirements of approximately 6,700 households. So floating solar PV is not only because of the efficiency improvement. We can, from these projects, we understand that the floating solar PV also significantly contributing to water conservation in multiple water bodies. And this particular project spanning across 75 acres, and it has a capacity to power around 7,000 households. So it is saving water for 6,700 households and can deliver power to 7,000 households and prevent a minimum of 46,000 tons of CO2. So how these floating solar PVs are useful for the country, for the humanity. Then there is a small scale also floating solar power plant in Chandigarh, 2 megawatt. So we can see that the facility contributes reduction of carbon dioxide by 80,000 tons per year, and it is also reduced significantly water evaporation by 382 million of liters annually. And this particular solar power plant, it is according to report, it generates 2.8 million units of electricity each year, resulting in annual revenue of 1.38 crore. So, and it was commissioned in 2023. So we can see from this project also, even installed in the small scale, but it is sufficiently contributing to the renewable energy sector. Then some other projects in some other projects also there in Andhra Pradesh, in Visakhapatnam. So which also having 2 megawatt capacity, and it was commissioned in 2018. Then West Bengal Power Development Corporation Limited also stepped into floating solar power generation through different projects. So CLN Terra, one of the subsidiary company of the CLN Terra International. So it is one of the global leaders for floating solar, and it is helped in installation of 5.4 megawatt power floating solar plant at Sagar Digi thermal power plant. There are some more floating solar PV projects going on in West Bengal. So we can see 2 into 5 megawatt in floating solar project at Raw Water Pond, number 4 and number 5 under commissioning at Sagar Digi. And then 10 megawatt grid connected floating solar PV project at Raw Water Pond 1 and 2 is under construction at Bokreshwar Thermal Power Station. Then a combined 7.5 megawatt grid connected floating solar PV project at Raw Water Pond 5. Then some mega floating solar PV project at Bakreshwar Dam is also now under planning. So that will be also a large scale floating solar implementation in the Bakreshwar Dam. So if we see the different suitable, we can say, floating solar PV installations sites in India, if we particularly look into the seaside where the large scale installations are possible. So we can see here some of the points: Gujarat and Daman-Diu area, Maharashtra, Goa, Karnataka, Kerala, Tamil Nadu, Pondicherry, who are in the west and south and southeast coastal areas. There are significant opportunity for the floating solar PV installations. So that means the India has a very high potential for different floating solar PV installations, and research should go on, and we can help from the academic researcher side. Definitely we can help in some of the points or some of the installations, even for taking maybe small problems from a large project. We can definitely help on particularly SPB installations. Some of the recent research articles, because what I understand is audiences are mostly academic researchers, and we have to do research, and mostly our research is on the laboratory scale. So I try to take out some of the papers. Those are I can see quickly in the Science Direct, and yeah, I put it here. So one of the paper, so we can say a comparative experimental study on the hydrodynamic performance of 2 floating solar structure with breakwater waves. So that particular project they have conducted in UK, and they were interested to study the effect of waves on the floating structures. So according to this particular research, it is understood that further research is required for to identify the effect of waves. They have understood that the arrays formed by the different floating solar PV installations, it has a significant, it is significantly affected by the different types of waves. And for selection of the particular floater structure for a particular location needs further studies to identify the type of waves in that particular location, and accordingly we have to design the FSPV floater structures. And further in-depth hydrodynamic performance studies are required. Then another study, which is comparative performance evaluation of ground-mounted and floating solar PV systems. So this particular study has been conducted in Ghana by a group of scientists. So in that particular study, they have tried to see the comparative comparison between the ground-mounted as well as floating solar PV systems by performance ratio, capacity factor, panel temperature, solar efficiency, daily specific yield, etc. So by that, they have understood that yes, it is true that the floating solar PV systems having a comparatively higher efficiency as compared to the ground-mounted solar PV systems. However, the metal frames, metallic components are subject to corrosion. So this need to be further addressed, and they have also suggested some of the solutions that elevation of mounting structure and adjusting of angle of inclination can reduce the chances of corrosion of the floating structures. So from the mechanical engineering point of view, I can say these are very important points, that how to develop the floating structure for the different solar PV systems. Then another paper, okay, this particular paper actually from my group. So our students in Malaysia are actually working on using CFD as well as means compression fluid dynamics, as well as using the experimental methods to understand the effect of different parameters in the sense the height, tilt angle, the effect of water temperature, the effect of the wind flowing across, above, or under the solar panel installations, how it is affecting the solar PV systems. So we have understood that at a certain height, the solar PV having means when we vary the height, the solar PV efficiencies are also changing. Definitely, it is obvious because the it is getting affected by the water cooling. When we install closer, comparatively closer, then the wind effect is comparatively lesser. When we increase the height, then the water effect is comparatively lesser. So there has to be some kind of optimization between the wind flow and water flow when we consider the wind and water both effects. At the same time, the tilt angle, those who are working in the solar PV system in the for the ground mounted devices, we understand that tilt angle has a significant role to play to have a maximum solar conversion. So that is also one another part of this particular research. Then some of the techno-economic assessments also been conducted by a group of researchers in India, Goswami et al. So we can see here there's some of the interesting facts that for a ground-mounted PV system and floating PV system, so they have mentioned about the PV panel cost, so which should be same, inverter same, civil structures same, BOS, since the cabling and all items also involved in this, so it's little bit comparatively little bit higher only in the floating PV systems. For the land, if we consider the cost, then land cost is there in the ground mounted photovoltaic systems, whereas for floating it is kept at zero, but definitely it depends on what kind of water surface you are using. Then floaters, there is a significant amount of cost. We can see it is $683 per watt. So if we compare to other pricing, right, it has a significant component per watt power. Then operational cost, it is comparatively lesser in kinds of floating power devices. So we can see that here the levelized cost of electricity production, because of this particular floating structures and some of the BOS part, else the levelized cost of electricity production is comparatively higher in case of the FPP systems, whereas the efficiency wise it is compared around 5% higher than the ground mounted system. So they have done a detailed analysis, so I put the name here. If anybody interested can go through for further understanding. Then there is another paper that is quite interesting, that they have combined the floating photovoltaic system with the hydrogen energy generation. So according to that group of researchers from Oman, they have mentioned that 79% of systems energy production of yearly annual energy production is produced from the floating solar PV system. It is fine. Now they are also mentioning here that the fluctuation in the solar PV production system has raised concern, and according to them, that when the in particular some seasons, obviously that floating solar PV generation, the electricity generation from those devices will be comparatively lesser. So on those cases, they also identified that some work from the water bodies, if they use as a electrolyzer for hydrogen production, it can be stored in the fuel cell and then supply the electricity. So a combined photovoltaic system, floating photovoltaic system with hydrogen energy production system can be more efficient according to them for generating the electricity, and also it will give a further contribution, particularly for those times where the electricity production by the FPP system is getting lower. So some of the seasons we can see that the FPP production rate, or the performance ratio we can say, is comparatively lower. Then energy yield in different floating solar PV systems as compared to ground photovoltaic systems, we can see here. So a number of researchers have conducted research. So we can see here. So in number of countries, Pakistan, India, Bangladesh, Maldives. So we can see a number of countries are there listed. And we can also see because those are research papers, so mostly in the order of kilowatt. So those are mostly laboratory scale research. Some are there with 100 kilowatt, and there is one paper, it is 1 megawatt. So what we understand from that is the efficiency or energy yield, we can say here, because it's mentioned in terms of energy yield, is in all the cases we can see here it is improved as compared to the ground mounted photovoltaic systems. So it is improved, and if we see the improvement, it varies from 0.6% to even 35.9%. So what I mean to say here is depending on how they have conducted their experiments or numerical analysis, and on what environmental condition or at what operational conditions they have used. Based on that, we can see that there is a significant, we can say, a range in the improvement of energy yield by the floating solar PV systems as compared to the ground mounted systems. We have also are looking into different aspects, our research groups. So in Malaysia, one of the research group is working. That is, I am also that project is particularly I have started in 2022. So that was my project. I got the project, and I also written for one PhD student that time. So one PhD student taken admission that one. So the idea of this particular project was to see the floating solar PV systems performance in the Sarawak tropic, means the place where I used to live, Sarawak, particular the East Malaysian condition. So how the floating solar PV system performance in that particular weather condition, because the humidity level is quite different to that of the other countries in that particular tropical zone, and also the water evaporation rate was different. So we wanted to see how the floating solar PV systems are performing. So our target was to do the simulation, numerical simulation using computational fluid dynamics to see the cooling effect and to optimize the effects of wind as well as water. Then another one was to see the height of the height and different parameters of the different design parameters for floating solar PV. And also we want to see the how the performance enhanced as compared to the ground mounted photovoltaic systems. So we have conducted some research and still it is ongoing project here. So what some means from the result side, we can see that at a certain angles, we can see the performance is better for the floating PV systems, and also the height. If we look into that, at a certain height only, the performance are getting better. So it is not necessary to be very close to the water surface as well. Then some other PhD scholars project, but he is looking into the floating solar PV implementation for the electric vehicle charging stations. Basically, in Mizoram state, we have electric vehicles. Particularly, I think 97% of the our electric vehicles in Mizoram is two-wheelers. So we are trying to develop some of the EV charging station using the floating solar PV system. So how it will work and what are the plus and minus. We'll be looking into that, and we'll be using the artificial intelligence and optimization techniques as well to improve the system performance and power management. Then there is another floating solar based project that is basically done for the standstill water conditions, not looking into the flowing water bodies, so or dynamic water bodies. So this is to see additional cooling effect, because at certain locations here, in particularly in Mizoram state, we have understood that water level is not that high, it is comparatively lower, and the water cooling effect on the floating solar PV will also be lower. So for such conditions, we can implement also, there is another way of passive cooling techniques. So we are studying numerically as well as experimentally to see the effects of passive cooling. Means it is a gravity based flowing method. So what is happening here, so your particular solar PV is getting heated here. So the heated fluid is going into the reservoir, then from there it is coming back, and again using the free convection it will lose the heat, and again it is going back. So in that way, we are trying to see whether passive cooling mechanisms can also be used for the floating solar panels. Now overall, if we are coming almost to the end. So overall, we can see here the floating solar PV systems having some of the components like solar panels, central inverter, transformer, transmission lines. Particularly, this particular area is not out of my context. I can say that these are electrical parts, and I just know the overall information only. Whereas in the mechanical side, we are working particularly on the solar floating structures, solar floating installation arrangements. We are working also on the mooring lines, anchorings, and then materials for the floaters, then materials for the mooring lines. So those are the some of the aspects that mechanical engineers can work as well. Now, key challenges for the floating solar PV systems. Now the key challenges means from the challenges only we get the different research components. So key challenges, number one, cost. So installation cost for the floating solar PV systems are comparatively higher than the ground mounted systems. Whether we can do something on that particular aspects, that we can develop some low cost materials that can be utilized for the floating solar PV systems, and that in that way we can reduce the initial cost. Then maintenance, if particularly floating solar PV systems require more frequent maintenance because of the water environments. So whether it's possible to improve the maintenance. Then site selection, it depends on what kind of sites available. So Based on the site also, we can conduct some of the research, site-specific research. Then safety issues, that electrical accidents, that underwater cables can cause electric accidents. So it is more towards the electrical side, that how we can provide more safer electrical energy transmission. And then some of the issues like drowning, aquatic organisms. So these two particular factors, yeah, means one can look into that definitely. Then environmental concerns like marine environment. So it can cause some corrosion. So on selection of the materials, we have to be careful on different materials of for different components of SPB systems. Then some of the design and material concerns like require specialist expertise for design and installation. So definitely the solar PV panels installations, the floating structures that need the design and installation expertise. Then corrosion is one of the areas that we have to work for the FSPV systems. So the decision about the choosing of correct mooring ropes and systems has a significant impact on the installation of the floating solar PV systems. And some of the materials like high modulus polyethylene fiber, that HMP, and then is also one of the things that being used for the mooring lines. And now it is being replaced by the high density polyethylene material. So whether it's possible to further to do some research to reduce further the cost of the materials. Some of the important points that we have to look into if we look into the materials. So the breaking strength of the roof, then roof splice qualifications. So how is the fatigue performance for a roof? Then how is the creep performance? Then tension fatigue, then static and dynamic stiffness of this particular roofs. Then the length accuracy, elongation, because elongation is also one of the factors if we are considering it for the offshore locations. Then risks of damage during the installation, then the underwater growth of that particular material. Some of the features that we need for the selection of the material is the lowest creep should be significantly lighter than the steel, but having good mechanical properties as steel. Good chemical resistance, because there is a salt in the water, so they should be chemically resistant. Then it should have also better buoyancy property. And then traditionally it is 3 to 4% elongation is expected for the mooring lines, whether it is for the floating solar PV. Previously I worked also in one of the project in the floating wind turbine installation. So in that project also I have seen the elongation expectation is around 3 to 4% to resist the structure against the different wave loads or tides. Then some of the future research areas that we can look into for the floating solar PV installations is that how does the FPV impact on the power system operation and what benefits does it provide? What are the costs and benefits for co-locating the floating solar PV systems along with the hydropower? Because for the hydropowers, I think in Tripura also some of the projects may be ongoing. Because when we have a hydropower station, there are dams and we have the water bodies. So what are the different cost and benefits for relocating the hydropower systems with FPV? Then what tools can be developed for the FPV analysis and how can existing tools be utilized? Some of the implementation point of view, that for the analysis from the investment opportunities and technical potential for that particular FPV area. Then techno-economic assessments, or we can say techno-economic socio assessments for potential projects. And then different unique regulatory and policy issues that is up to the government bodies. Then monitoring and evaluation. Then monitoring the existing systems, and also what are the different benefits that we can get, or what are the different drawbacks that is there with the FPV systems. and how to mitigate those drawbacks. We have to work further. Then research and development for build for purpose of PV systems, what different structures we can implement, and as well as how we can have a better design for the PV systems to reduce the equipment weathering or erosion problems. So there are ample scope is there for different research in the floating solar PV systems. So a kind acknowledgement with for my co-researchers or students who directly or indirectly contributed to some of the components of the slides. So thank you and go green.
Thank you, sir, for your valuable speech. Now, I would like to request participants, if you have any questions, you may ask our resource expert for this session. Participant, please.
Yes, sir.
Yes, you may ask the
Uh,
question, sir, if you have any
Yes,
question.
sir.
Please.
Yes, sir. Thank you very much for the presentation. My question is that whether it is a feasible, sir, or economical to have the floating solar plant.
Yes, sir. Number one is feasible. That's why we have seen so many projects here in across India. Different projects are ongoing. Is feasible. When we talk about the economical, sir, at the present stage, it is these. If we consider the levelized cost of electricity production using the floating solar PV systems, it is definitely higher as compared to the ground-mounted solar PV systems. But when we consider the different other aspects means the water evaporation rate is it is significantly lowering. We have seen some of the projects claiming that they are reducing the evaporation rate by 60 to 70%. So it is a significant boost to the environment. Number two factor is sir, here we have to also consider that in the long run, the main contributing here is that the structures, the installation cost for the floaters. Now, in the long run, it may be reduced further. But as of now, we can see that if we consider the economics as a strict point, then definitely from the economic point of view, the floating solar PV systems are more costlier than the your traditional ground-mounted solar PV systems.
Any more questions from participants? If you have any question, you may ask the question to our expert.
Hello, sir.
Sir, hello,
Uh,
madam.
Sir, your topic is very interesting. I have enjoyed a lot. Sir, what I understood that the stagnant water is required for this floating solar power plant.
No, madam, it is not compulsory to have stagnant water because many of the projects are now undergoing for the offshore locations where we have the effects of tides and waves as well. The thing is here that for the dynamic water conditions, we need to have the proper mooring lines and anchoring facilities, and the mooring ropes that we will be utilizing. For that, we need to have certain elongation flexibility. We have seen that some of the projects having elongation flexibility of 3 to 4 degrees. So yeah, if we have proper anchoring and mooring facilities, it definitely it is one of the important you can say energy contributors for the future. If we particularly see the map of India, the west coastal area, the southern coastal area, and the eastern coastal area, there are ample opportunity, madam, for the floating solar PV installations. And I think Indian government is also looking into some of the large scale projects of installation in those areas.
in the large water bodies also, that is for any park also or water park, we can install that, no? And that is the
Yes, sir. Yes, madam. That is means more beneficial. If we can have those stagnant water bodies, is definitely more beneficial, economical. We can say because we can use the hydro dams. So for hydro dams, we can definitely use this floating solar PV installation. And most of the Indian projects at the moment are based on those hydro dams. But at the same time, there are a number of projects ongoing. In China, I have seen one project that they are arranging in the offshore location, that one. And that is one of the very large scale projects of more than 100 megawatt capacity. So if we have those potentials, having hydro dams, particularly in Tripura case, I think in Dambor also, there are some works going on the floating solar PV installations.
okay, sir. Thank you, sir.
Yeah. Thank you, madam.
Any more questions from the participant side? If you have any question, you may ask our expert once again. I would like to request the participants, please. So I think that there will be no more questions, sir. So, sir, I would like to once again thank you, sir, for having, in spite of having a busy schedule, you have given an opportunity to deliver your valuable speech with us and share your valuable knowledge about the floating PV system, and you have delivered a valuable that is the knowledge about the global scenery of the that is the solar power system as well as the floating PV system. So once again, I would like to thank you, sir, for having giving us the such opportunity with your valuable knowledge, sir. Thank you, sir.
Thank you, sir, for invitation also, and I congratulate the whole organizing team for this successful FDP.
Okay, sir. Thank you, sir. Thank you, sir. So now I would like to hand over the session for the next session to our Kabiri madam. Thank you. Thank you, sir.
Okay, 15 minutes left to start the next station. We shall wait for 15 minutes. Otherwise, you can leave now or you can join before 7:30. That may be possible.
Okay, ma'am.
Any participant, if you have any opinion whether to join the program again or you continue this program. Link will be same. Okay. I'm trying to contact the next speaker. If he join, then we can start also. Okay. Please wait for 5 minutes.